Greetings, everyone. My name is Martin Ketting. I'm from Rat River Technologies, and today we're just discussing multiple user Mumimo and how it relates to the 3000 product. A number of you have been asking as the 3000 product comes into production about what does that mean for throughputs, etc., and how does it actually work. So we're going to basically just very briefly describe it. Now, I'm not going to talk about multiple or the Mumimo aspect. There's lots of videos on that. It has been part of the Cambium product line for a long time. So if you want to, you can go back to other videos and take a look at how that works. But what we're going to do is we're going to focus on the multiple user part of it. So there's a couple of things that you really need to know about the multiple user portion of how this works. So there's a few things that you need to know. The first one is there has to be supported products, supported hardware. So for example, in the 450 product line, multiple user Mumimo has been around for some time, and Cambium has pioneered a lot of the new features in multiple user Mumimo. You obviously need the AP, it's called the 450M, and then you need the SMs. Now, all of the 450 SMs already have that feature in it. It's built in, it's part of the product set. For the ePMP, it's a little bit different because the ePMP is based on an 802.11 Wi-Fi chipset. It uses a Cambium specific MAC, but it does use that chipset, and so it's dependent on that chipset supporting it. So the way this works is that 802.11 AC Wave 2, so AC came in a couple of different versions. So Wave 1 did not have multiple user Mumimo, Wave 2 does. So the ePMP product really requires to have that Wave 2 AC product line, which is available in the 3000 product as well as in the 3000 series SMs, and the first ones of those are called Force 300s. Now you might say, well, what happens to my 2000 products or the 1000 products? Are they supported? Yes, they are backward compatible. However, you have to keep in mind that even if you put up a 3000 AP, the 2000 doesn't understand the AC chipset. It's not built into that product, so it will operate as normal. It just will not have the features. It will not be able to participate in the multiple user portion of it. It has a little bit of benefit just because of the 3000 antenna system, etc. The second major thing is that the SMs need to be accurately located through a process called sounding. So the AP sends out a message saying, where are you? The SMs respond, and of course, because they've got that new chipset, they can respond back and forth. So they have to be accurately located. The third thing is that there needs to be sufficient spatial separation between the SMs. And I'll show you that in a second. And then finally, there has to be sufficient data going to multiple SMs in order to make use of that. If you only have a little bit of data and it's only going to one SM, obviously there won't be any multiple user because there's no need for it. So this is what it kind of looks like. You've got an AP up on a tower, you've got a couple of SMs, and you've got enough data to meet that, and you've got that spatial separation, and therefore the AP can actually simultaneously send data to both of those SMs. So what does spatial diversity mean? This is kind of a full chart, so I won't go into a lot of details, but what you need to know is a few things. So, for example, if I had two SMs, both in line with each other, one behind the other, the AP would see that as 0 degrees of separation, and therefore it could not distinguish between those two, and therefore it could not actually send multiple user data, even if it had data for both of those SMs at the same time. However, if one of those SMs was ideally about 20 degrees away, a little bit plus, minus, etc., then the AP could say, oh, now I can actually separate them from a spatial separation, and therefore now I can group them and send data simultaneously to the radio. So in ePMP, the ideal is about 20 degrees. It does work in other angles as well, but that's kind of the ideal. So let's take a look at it from a practical standpoint. This is an AP. It's got 6 SMs. They're spread out. So again, if I had these two SMs that were, basically right behind each other, in fact, they are about 6 degrees separation, for example, the AP would not be able to really distinguish between those two SMs, and therefore it wouldn't be able to group those. So those two SMs could not actually communicate exactly at the same time. However, if you had data going to these two SMs, the AP would say, oh yeah, they're able to be spatially separate, therefore I can actually send data at the same time to those SMs. So what does this kind of look like? Well, if you had an AP with one SM, you wouldn't be able to actually use any of the features of multiple user MIMO. You would be able to use the higher capacity of the AC chipset, etc. So you'd get about 118 meg down and 36 up approximately if you had it set at 75/25 in a 20 megahertz channel. If you all of a sudden went to 5 SMs, or more than one, obviously, now the AP ideally would be able to find groupings of customers that it could send data to, and then you would jump up into, approximately, if you were using the highest modulations, etc., you would get about 230 meg down and 28 up. Now, again, it's all dependent where the SMs are, how far they are, their signal strength, etc. But those are kind of the ideal numbers that you could get. So that kind of gives you an idea of what multiple user MIMO does and how it works. And hopefully that it will answer some of your questions. So thank you very much for watching, and we'll see you again.